Okay. So we are talking about this XML, right? So this is XML structure, but this is a WSDL. Okay. So you can clearly see there is some header information here. If you see here, right? So first tag is your WSDL definition. Okay. Inside that, you can see that what all XML namespaces are getting used. So these namespaces are having a data. If you look at this one, the first one is a SOAP. Second one is your TM, which is a text matching. Then we have something called encoding. We have something called MIME type. We have something called SOAP 12. So these namespaces will be used to, logically group your, tags. Okay. So now the first tag, it's defining, it's a starting, it's a root tag of your document, right? And it's clearly said that it's a WSDL document, right? So it tag itself will define the definition of your SOAP web service. Okay. Then what all types we have? So if you look at this, we have types, we have messages. And I clearly told you, right? If I go back to my documents, if I go back to new document, right? So we said, right, whenever there is a SOAP web service we are talking about, it always takes the request in XML.
XML. Yep.
And gives the response in
XML.
XML, right? So this is your request. This is your response. Now in SOAP, we need to not only we're talking about request and response, we need to talk about what all methods are available. So if you're providing some service, you need to tell that what kind of service you are providing, right? Whether you're creating resources, whether you're deleting resources, we are updating resources, all that information. And all these methods will be accessible only on post, right? That is the standard of SOAP. So that's the reason SOAP has a restrictions. It's a little difficult, right? And it has a specific data format, XML only.
Yes.
That
so
means
it is used for create only, right?
Sorry?
It is used for create only.
No. It's used for all these methods. Get, if you want to retrieve the data, if you want to create the data, if you want to delete the data, in all the cases, you'll be using post method. And you are not going to use the get or put or patch. You'll be having a specific method over there. For example, if you clearly see here, there is a method called, if you go in WSDL type, there is a schema, right? Inside schema C, there is a add method here. See this one.
Okay, yeah, name add.
Yeah, it will generate add response. So here there is no specific HTTP method, but the method here in the WSDL that will define the operation. In case of REST API, what does, if you remember properly, yesterday we talked about HTTP methods, right? Get, put, post. In case of REST APIs, those HTTP methods will decide the operation.
Operations, okay.
But in SOAP, this WSDL will tell you, okay, which method is doing what.
Okay. Add means adding something.
Yes, add means adding two numbers. Is clearly here, int A, int B. We are going to consume this web service in our one of our use case. Okay, that time I'll clearly show you how to send the request to SOAP web service. So we are consuming. We have a session for consuming SOAP web services, consuming REST APIs.
Okay.
Okay. So this XML document, you need to understand that there will be always a root tag. Inside that there will be a child tags. Inside that there will be a grandchild tags. It will go in hierarchy. So each tag will have start and end. Okay, and each start and end has a meaning. Okay, so each tag will have start and end. That's the reason when we talked about XML, right? It's a little lengthier or little bulkier than JSON and CSV file. So whenever you are sharing, if you want to share the data on network, right? What we use CSV file. That is the list size file. So if you want to share the same information in XML, JSON, and CSV will take very less amount of space. Because if you go with the CSV format, right, in the first row itself, it will talk about columns, and the rest of, so this will be your header, and rest of the rows are all data. So you don't need to tell again what it will be comma separated, right? If you see the CSV file,
Yes.
only first row will talk about what all these values are.
Got it.
If you go to JSON always will be having key and value. So that means you are repeating key again and again. But in case of CSV, only once you are giving information about the keys, and rest of the records will be your data records. So CSV is the best of sharing data over internet. Then comes the JSON. If you are talking about request and response, to properly play with request and response, JSON is the best option. And then finally, if you are not having option to use CSV and JSON, then go for XML. Clearly?
Okay.
So
Yep.
for JSON to process JSON, we have inbuilt libraries, and it's very easy to process JSON. It's more readable. Okay.
Yep.
Okay. So what I have decided today. So if you go and look at my agenda today, so in the previous classes we talked about role of MuleSoft. We talked about tools. Hope you have created Anypoint account so far, right? And we have discussed. Yeah, we have discussed about the components and their capabilities. So let's log in and let's see where we are actually.
Right now, I'm middle of the project, so I have used Anypoint platform as well as web as well, and desktop app as well.
Okay, so you use Anypoint Studio, right?
Yep, I'm creating some apps. I'm building some flows.
Okay, good. So let's talk about today's my agenda is to let's discuss the API lifecycle and API-led connectivity. Why the MuleSoft is so famous and it's so competitive right now in the market. Okay, what's the reason behind it? Okay, so we'll talk about API lifecycle right away.
Okay. So, can you
Yes.
tell me how the questions are also asked in the exam, or can we?
Yeah. So whenever I'll be picking the topic, right? That time I'll tell you that, okay, this question. So for example, if you're talking about the error handling, right? That time I'll clearly tell you that from this section, this is a very famous section for your dev certification. Okay, so from this section, error handling section, you'll be having minimum 6 to 10 questions. Okay. When we are writing our API design, that time I'll tell you what all questions will be coming in our exam. Okay. So whenever we'll be covering topic, that time itself I'll tell you that, okay, these are the questions or the area where you'll get the questions.
Okay. From last two lectures, it will not cover the exam questions, right?
No. Because we are setting a context, we are setting a base, right?
Okay.
We are just setting up our environment right now. So our intention was to why MuleSoft is there first of all, right? What is the role of MuleSoft in current situation, right? So we put that situation first. Okay, so we saw the pain points, and then how MuleSoft was helping us to mitigate those or helping those to avoid those pain points. Then we saw that what tools are required to complete this training, right? And then we created step by step. We are coming now. So we have created a Anypoint platform account now, and on the Anypoint platform account, we have discussed few components, right? So we have discussed something. We are not discussing in detail. We are going to discuss those in details whenever we are covering that topic. Correct?
Got it. Yeah.
So we talked about DC. We have not created anything over there, but we talked about DC, where what we can do here, we can write our specification. Okay, we'll use RAML language over there. This is what we have discussed. Then we talked about exchange, right? The exchange is something which is a marketplace for our organization. So whenever we are creating any asset, we'll be we'll be publishing our assets over here. So there's a marketplace for examples, templates. You can put policies. You can create your policies and you can publish the specification. You can publish your connectors. So whatever you wanted to reuse, you can go ahead and place it on the exchange. Okay. Then we talked about something called access management, right? In the access management, we have seen we are actually talking about the access. So how to create users, how to assign them permissions, how to create a team, how to create business group, how to create environment. These things we have discussed in the access management. Plus, we discussed about connected app. Not in detail, but I gave you enough information to what is connected app. Then finally we talked about external access. Hope you remember external access.
Yep, last we covered that.
Right? And then there are two things: identity provider and client management. This identity client provider and client management, these are architect level stuff. No questions from this. There won't be any questions from identity management or client management in the certification. Clear?
Okay. Got it. Yeah.
Okay. So now let's go back to our today's session. Okay. So let me bring this. Are
any other members will join us or?
No, that's fine. I don't want to wait for anybody. Okay. Yeah. So it's their responsibility to connect.
Yep.
Okay. Okay. So now let's come back to the point which I was planning to discuss. So this is what we are going to discuss today. So let me copy this, and better I'll open the Jamboard today, so it will. Okay. Is this visible to you?
Yes, but not in detail.
Okay.
Okay.
So I'll talk about it little detail. Okay. So now hope this part is visible to you. This part is visible to you, right?
Yep.
Okay. So this is the main part we'll be talking about. Okay. Now, when we're talking about API lifecycle, so we are talking about entire journey of our API from where it starts and where it will go. Okay. So first it start with the design. Now, in every stages, we'll talk about what all tools are available on our Anypoint platform. Okay. So if you look at my screen right now, we have design. So in case of design, the moment you get the requirement, okay, the moment you get the requirement from the client, we'll analyze the requirement and we'll start writing the specification. Now we have two options to write this specification. We have either Anypoint Studio. In Anypoint Studio also we can write the specification, or we have Design Center. These two tools are provided by Anypoint platform free, right? We can use these tools to write our specification. Now you can write this specification in multiple languages. You can write either in RAML, or you can write in async. So there is async. You can write in OA as Open API specification. You can write in RAML, you can write in async, you can write in OAS, that is Open API specification. The RAML and the OAS, these are for REST APIs, synchronous API. There are two concepts called synchronous and asynchronous. So for synchronous, RAML and OS. For asynchronous, there is an unsync API. So if you go to your Anypoint platform, right? Once you logged in, if you go to your design center, we'll talk about parallel, we'll talk about which component we are talking about. So this is the design center. We have Anypoint Studio. The latest version is our 7.14. So I hope you'll download 7.14 and you'll start using it. We'll use latest stuff. Okay.
Yep, sure.
So if you go to this and design center, so in the design center, we can create this many things. Okay. We can create new specification. We can create a fragment. We'll talk about all these things. Let me just put jargons right now. You can create even new Mule app, which will be very, very straightforward app. If you want a complex app, then definitely you need to use the Anypoint Studio. Here it will be straightforward. Source, target, mapping. That's it. Then I told you, right? Async API. This is one more language where recently it's get added to our Anypoint platform. It was not there earlier. So this is for asynchronous API. This is for event-driven architecture. So for event-driven architecture, now we can write a specification. Earlier it was not there. Okay. Now I told you, right? We can use this design center, or we can use Anypoint Studio. In Anypoint Studio also, we can create a project for API specification. Okay. Now let's say if you start, say, I want to create a specification here. Look at this. These are the languages available. See, RAML 1.0, that is latest. We have RAML 0.8. We have OAS. We have OS 2.0 and OS 3.0. OS is nothing but, if you remember, if you are coming from Java background, or even not from the Java background, in the Java there is something called Swagger. Okay, to write the documentation. Now that Swagger is only renamed as Open API Specification.
Okay.
Right? Open API Specification.
I'm not from Java background, so I'm not sure.
Just for the documentation. Okay.
So
we see that how this Open API specification looks like when we start writing our specification. Clear? So first stage is design. Okay. So once you design, you'll use a tool, either Anypoint Studio, Right now the version is 7.14, or we can use design center. We can use either RAML language or OS. RAML 1.0 we are going to use. OS 3.0 we are going to use. Okay. In this case also, we can go with the manual approach, manually writing everything, or we have visual interface also. Visual interface to write.
Right now, RAML 2.0 is there, right?
No, not supported by Anypoint platform right now. Okay.
Okay.
So the older version is 0.8. Okay. Now in the 0.8, few things are added, and that becomes 1.0. What are those few things we'll talk about when we'll be writing the specification. Hope that is clear to you. Right?
Yep. Got it.
Yeah. So this is a phase where we'll be designing our API. Plus, we'll be, before publishing it to the exchange, we'll be testing also. Okay. So for testing, the design center provides us the mocking service option. Mocking service. This is also available inside our design center itself. We don't need to pay anything for this. Now with this mocking service option, what will be, whatever we have written in the design center, okay, as a API specification project, either by RAML or OS, we can test it by using mocking service and mock data. Okay. So by testing via mocking service and mock data, we'll be making sure that whatever requirement I have received from the client, okay, whether that requirement looks fine or not. Whether it is as per the expectation, as per the requirement, whatever I have written in the design center, is that matching or not? Okay. Once I'm comfortable with this testing, the mocking service testing, okay, then I'll go to the next stage, which is my publish stage. If I'm comfortable, then only I'll go to stage number 2 called publish. Now to publish is nothing but you can share this specification either with the client who actually give you a requirement or your org members. Okay. Or you can even make it public. So public, if once you make a public, either your client itself can see from there. This public means you're putting it on the public portal. The moment you publish your specification, right, the specification will give you the moment you publish it to the exchange. So what tool you are going to use? We are going to use a tool called Anypoint exchange. Now, the moment you publish it to the exchange with your specification, just like we have seen the mocking service in design center, we'll get here API portal. And via API portal, you can test your specification. So that means you can, exactly like a mocking service, your client can come and see on your API portal and test your specification with the help of mock data. And in design center, you are confident that your specification is exactly like mapping with the requirement. Now client also will see here, and client also will see the results, mocking results with the help of mock data, and he will give a feedback. Okay. Now he will give feedback whether he is satisfied with that specification. We have not implemented anything so far. Everything is there in the mock. Okay. Everything is with the mocking data. Nothing has been implemented so far. We have just written the specification. So now if your client is happy, your org members are happy. If those guys are not happy, then we'll be going back to design phase. Because based on their feedback, if the feedback they said like, no, I didn't want this specification like this. I just, or this specification is not as per the requirement, then we'll be going back to design from the publish. So this we'll be going in iteration. Unless there are no comments from the client or from the org members, you cannot finalize your specification. So you need approval from your client. Whoever gave you a requirement, you'll be asking for approval. Okay. Approval means you'll ask them to review. Once they are happy, there are no comments, then from the design to publish, then from the publish, you'll be coming back to the implement. Right? You'll come back to the implement. Let's talk about implement. So far what we have discussed for design, we'll be using tool called Design Center or Anypoint Studio. The language is fixed, RAML or OS. We'll be testing our specification. Once we are done with our specification, we'll be testing by using a tool called mocking service, right? Mocking service, and we'll be using language OS and RAML. Now then we'll come back to, or we'll expose it to the exchange. That means it will be available for review, for testing, for other members, not you. You already done in the design center. So in exchange, other people will be looking at your specification. They will using API portal to test, and then they will decide whether this specification is as per the requirement or not. Okay. Then only, because till that point, you'll be in iteration. They will give some comments. You'll go back to design center. You'll fix it. Again, you'll publish it. Again, ask them to, oh, now can you review, please? Can you see the results now? Is it fine now? Once you get the approval, okay? Once you get the approval, then you are in safe hand now. Now you can go to the third stage called implement. Okay, for implementing, again, I said, right? Either you can use design center. If your implementation is very simple, generally we go for Anypoint Studio.
So we are going to use Anypoint Studio more, right?
Yes. Okay, this is a story till today. Now there is a plan to launch something called Anypoint. I'm not sure whether you are aware of it, or Anypoint Code Builder.
Okay, no, I'm not aware of this.
Okay, Code Builder. Anypoint Studio is on Java based. Eclipse. Anypoint Studio is actually wrapper on Java based Eclipse. Anypoint Code Builder is VS Code. Okay, this will be on top of VS Code. So clear so far?
Yep.
Okay. Now for implementation, you are not going to write your implementation from the scratch. In the studio, when we'll be creating project, we'll be importing RAML from our design center or from Exchange. So you'll get a RAML from there. So the moment we start, say, create new project, plus you'll use a RAML. Either from design center or Exchange. So this will give you a skeleton. So this skeleton will be nothing but you'll get a Mule Flow, Mule app basically. In this app, you'll be having multiple flows. Okay. Now this number of flows is nothing but how many flows you'll get it in this application is equivalent to number of flows. There is a formula, okay, is equal to 2 plus, I'll tell you what is this 2 means, number of resource methods in your spec. Okay. So for example, in your specification, let's say you have user, under user you have get method, post method. That means for get method, one flow will be there. For post method, one flow will be there, plus extra 2 flows will be getting. So that means total 4 flows will be there when you are creating a skeleton from your RAML. Okay, what are these 2 flows?
What 2 flows? What another 2 flows? One
yeah, I'm coming to that. I'm coming to that point. But is this clear now?
Yeah.
Okay, so these 2 flows are nothing but, I'll come back to that point. So 2 flows. One flow will be a main flow, which will be a router, or we can say routing flow. Okay, and second one is your console flow. Now this console flow is exactly API portal, which you see on Exchange, or mocking service, which you see in design center. So to run from the Anypoint Studio, you need this console flow. Okay, to run from your Exchange, you need this API portal. To run your specification from your design center, you need mocking service. Hope I'm clear with everything. So these are these 2 flows. Always you'll get it. That's the reason I said 2 plus number of methods in your specification.
So console flow will be used
to generate this API portal, whatever I'm talking about, right? API portal and mocking service. This responsibility is given to this flow, console flow. And the routing. Okay, so I told you, right? So there is a resource called user in your specification. And there is a get method. There is a post method. Okay. Now we'll be getting only one listener, HTTP listener, single listener in our skeleton, and that listener will be having path something like this /star. Now when I'm saying give me a user get method, right? So I'm asking for get, then I'll be asking for post. So all these requests will be coming. Let me again draw one diagram. So you'll be seeing a flow. So this is your Mule flow or Mule application, I'll say. One flow is dedicated for console. One flow is dedicated for routing your request. Routing request. Now, why I'm saying routing request? Because for this entire application, there will be only one entry gate over here. All the requests, whether you are calling get method, whether you are calling post method, everything will be coming to this gate only.
Okay.
Now, for each gate or post, I told you, right? There will be a dedicated flow. Okay. Right? So one for get, one for post. Now this routing flow will decide whether to send this incoming request to get flow or post flow. This flow will decide. There is something called API kit router over here. That API kit router will decide where to send the request. API kit router. Now API kit router will identify the incoming request, whether it's a get request or post request, or it is for user resource, or is there any other resource over there, let's say contact or some other resource called employee. So this will get identified by, say, in one specification you have 3 resources. On 3 resources you will be having multiple methods, right? Correct? But all these requests will come to this point only. This is the entry gate for your entire application. And from here, all the requests will be routed to the specific flow. And how? By using API kit router. And how this API kit router will take the decision which flow has to supposed to be picked up for the incoming request. This API kit router uses behind the scene your specification only, which we have imported from either design center or exchange to generate this skeleton. Am I clear so far?
Yes. But can we see the practical scenario which you are talking right now?
Yes. I'm just talking about right now the basics, right? We are going to create design. We are going to create the specification. Okay. So, but still I can show you one example. Okay. So let me bring something. Let me check whether I have anything right now, or I'll pull one and I'll show you.
Yeah, so, that will be more beneficial to understand.
Yeah, I got your point. Okay. So I'll bring my studio. If you look at studio, right? This is how you'll get API main flow. This is your main flow. Okay. And you'll get a console flow. Are you able to see my screen? And this rest of these flows are right. See here. This rest of the flow, see get method for platform metrics, get method for a post method for platform metrics. All these flows are generated based on the specification. Okay. So whatever methods are available in that RAML, for those methods, these many flows are getting generated. So these are 2, API main and API console, and rest of the flows are coming because there is a specification. In that specification, these methods are there. So let me get that either if I have that API specification RAML. Yeah. If I open this RAML, okay, if you look at this RAML, see platform matrix is there, resource, right? On that, there is a get method. See, there is one more resource called load. On that, there is a post method. See, there is a business matrix resource. Now, if you go and look at the see here for platform matrix, get and post. For business matrix, see here, there is a get and post. For SDLC matrix, let me see in the RAML SDLC is there or not. So if I minimize a little bit, see SDLC matrix resource is there. There is a get method.
Yeah.
Right? Definitely there will be a post method also. See, post method is there. Right? So for SDLC, for business matrix, and for platform matrix. So there are multiple resources here. See, platform matrix, business matrix, SDLC matrix, and for each resource,
we have different flows.
We have dedicated flow. See here. Clear?
Yes.
Plus, we have two flows. Now, in main flow, if you look at it, there is a API kit router. This is what I was talking about. Now, if you look at the listener, this listener, I wanted to show the path. Let's look at this path. Okay. Okay. So if you look at this path, ideally, you will get a path something like, so right now it's externalized, but the path will look like this. I'll tell you. Okay. /API/star. Okay. So that means all the calls after API, whatever you write, it will come to this listener only. So you say API platform matrix, API business matrix, API SDLC matrix, all calls will come here. Now, on that resource, whether you are calling get method or post method, that's up to you. But API kit router will take a decision now. How you will take the decision? Let me show you. So there is a configuration here, and this configuration is behind the scene uses the same RAML file. Okay, so let's open it. Okay, so you got my point, whatever we are discussing. Now see here, it's actually pointing to API matrix-toolkit-api.raml. Same file, right? See the left-hand side? It's under API folder only, correct?
Yeah. Okay.
The same file. So that it will, that the API kit router will look into the RAML, and from the RAML, it will take the decision where should I, divert or route this request, incoming request. Are we clear so far? Whatever I am talking about?
Yes.
So console flow, it is responsible for portal. Okay, so when we'll be writing and when we'll be importing, I'll show you. Once we run this, we'll get API portal. Okay, just like the portal which will be visible on Exchange. Clear?
Yep.
Okay. Okay, so this is about the implementation. So we are done only half right now. Now what we'll do? Now these gate flows, right? And these flows will be having a mock data. Okay, so already hard-coded data will be there. That is called mock data. Now we don't need mock data, right? When we are implementing, we'll be actually connecting to the databases or external services and all that. So we'll be replacing this mock data and we'll be putting actual connections to the actual target system or source system. If you're sending the data, we'll be building connections for the target system. Or if you're pulling the data, that means the source system will be building connections for the source system. It can be anything. It can be SaaS application. It can be a dedicated database, or it can be your local database in your data center. It's up to you. But we'll be replacing this mock data by actual data coming from the actual target system or source system. Okay, so we are not going to use this mock data, but we'll get a skeleton and we'll get a places, we'll get those placeholders will be replacing with actual logic. That's where we say we are going to implement it. Okay. So here we'll be writing our actual business logic. We'll be connecting to the actual target system, actual source system. Clear? So this, whatever flows we are getting it, sometime we'll be replacing those flows completely, but this connection will be always there. This connectivity has to be there. You cannot break this connectivity. Okay. So this connectivity will be there. We'll be adding our business logic under this flow. Clear?
Okay.
Actual business logic.
Got it.
Okay. Now, once you have written the business logic, you need to test it, right? So in Anypoint Studio, what we have for testing? Okay, in Design Center, we have seen mocking service. In Exchange, we have seen API portal. Now, what we have here? Once you run it, definitely you'll get a console. Via console, you can really see how the request goes, how the response comes. Now, if you want to test the multiple scenarios, okay, for this input, how my flow is behaving, for this output, how my flow is behaving. So for multiple scenarios, you want to test. So you need to write the test cases, right? So writing test cases, we have tool something called MUnit. And this is embedded inside our Anypoint Studio itself. If I wanted to show you, you can simply go ahead in your Anypoint Studio and you can simply say right click on that flow and you can write a, so if I go here, go to Mule Flow, right click on that flow and you can say create MUnit test cases for this particular flow. And then you configure your MUnit based on your requirement. So we have two ways of configuring. We have dedicated session for writing MUnit test cases and all that. So we'll see that in that session. Okay. So we have MUnit dedicated session for this. Clear? Okay. So we'll be testing our code in Anypoint Studio itself. So during development phase itself, we'll be using MUnit to test our code. So while MUnit, we'll be testing the code coverage also. So sometime when you write a code, if your code coverage is not greater than 75%, right? They won't allow you to deploy your code. Okay? Because if your code coverage is not 75%, then they will not allow you to deploy this code in production. So you need to write a test cases which are actually covering your code or reaching your code more than 80%. So we need to write the test cases in such a way that if I run my MUnit test cases, all the test cases will cover my code and it will touch each and every component of my applications, and then the code coverage will be generated for us. During the test cases, these all components are executed, and this is the code coverage report. Okay, so this code coverage report will be generated, and this percentage will be compared with the configure value. You put some threshold value over there, and that threshold value has to have this value greater than that threshold value, greater than or equal to. So if you put 80 as a threshold value, right, this code coverage has to be greater than or equal to 80, not less than. Okay.
Got it. Yeah, I got that.
Clear, right?
Yeah.
Okay. Now, so if you see we have covered design. From design, we go to publish phase. From publish, we went to our implementation. In implementation, we went to the testing. Now the test, while development itself, we do the testing, right? That testing, we call it unit testing. Okay, so testing has multiple. That's the reason I am writing down over here. Okay, unit testing means whatever you have implemented, that box you are testing it. So that is your unit you are testing. Okay, now you will deploy the code to QA and you will do integration testing. Integration testing is connecting all the boxes and then you are testing it. So integration testing has to be done in integration. In the QA. So this will be done in QA or test environment. This will be done in dev environment. Dev, I mean when you are developing, that time you'll run unit test cases. Okay.
Yeah, got it.
So this kind of testing, then there are multiple testings, guys. Okay. So there is something called load testing. Okay. So load testing is you actually what you do, you'll create an environment similar to the production. Okay, because load testing, what you are trying to say here, okay, my actual service is going to handle this much load or not. That means that actual service is going to run in production, correct? So you should have a similar environment with the same kind of infrastructure, same kind of traffic you need to have, right? So you'll be doing this testing in an environment which is equivalent to production. We call it UAT, user acceptance test environment.
Yes.
Okay, so UAT, or sometime we call it staging or some blah blah name they will give. So this load testing, performance testing you'll be doing on. There is no point of doing load testing and performance testing in dev environment, right? Dev environment always will be free, always will be performing well, right? But when your environment is having load, it's having already traffic, in that if you test it, that is actually real number, you'll get it, correct?
Yes.
So for that you need to have proper environment which is exactly replica or identical with the product environment.
Yeah.
Hope this is clear to you. So that is your test environment or test stage. So we are going so far: design, publish, implement, test. Now once you test it, right? So for during this test itself, right? If you talked about QA environment, now if you want to perform the integration testing, definitely after implementation, there is a stage called deploy. Unless you deploy, you won't get code in your QA, correct?
Yeah.
So that's the reason I'm coming back to point. I'm just linking, I'm connecting all the dots now. So for deployment, we'll be writing our CI/CD pipeline. We are not going to go and do manual deployment. Yes, there is a way to do manual deployments. We'll be implementing CI/CD pipeline. And for this also, we have dedicated session. How to write CI/CD pipeline, and we'll be using a code repo for it.
Code repo. Okay.
Code repo.
Code repo. I have used Jenkins. I have used Copado.
And build a tool. Whatever you're talking about, Jenkins is a build a tool.
Yeah.
Okay. But in this scenario, we are going to use something called GitHub.
Okay.
Okay. GitHub plus GitHub Action. GitHub for code repository, GitHub Actions for writing CI/CD pipeline.
Okay.
Okay, clear? So we have dedicated sessions for that. I don't want to go inside this, but what CI/CD pipeline will do? So whenever you implement your code, right? Now you'll be source controlling this. So before deploying, one more stage will come called source control. So when you do the source control, the moment you are okay, you are confident that your test cases are working fine, your unit testing is working fine from the implementation, which is part of. So I can say this is a part of testing, right? So we have 3 arrows over here. That's the reason I draw 3 arrows. So you do the unit testing, you source control your code on GitHub. Either use GitHub, either you use Bitbucket, either use GitLab. There are multiple code repos based on your client. Whatever code repo they have, the way of source controlling the code is same. Okay. So you'll be using either Git desktop or Git manual commands.
I have one question. Anypoint today is using GitHub, right?
No. From the Anypoint Studio, you can use GitHub, you can use GitLab, you can use Bitbucket. Just need to give that code repo URL in your Anypoint Studio. That's it.
Okay.
Okay. So you need to give your code repo URL there and credentials. The moment you give those code repo and credentials, it will take your code to the code repo. Either you can use Anypoint Studio to source control the code, or you can go to the command line and run these Git commands. So Anypoint Studio internally using Git only. So Anypoint Studio has internal Git plugin.
That's what I was asking.
Plugin, okay. Git plugin is used to source control the code to GitHub also, GitLab also, and Bitbucket also. This is the same Git software. GitHub is a UI. This is a web application. Git is a software, actual software to source control the code. Clear?
One more thing. We will write the unit testing in MUnit, right?
Yes.
And that can be used for QA and UAT environment as well, right?
Yes, yes, yes.
It will
But
be
unit testing, generally what you do, you only runs in a dev environment.
Yeah.
Okay. QA environment, we do the integration testing. UAT means exactly I need a production equivalent environment. So we'll be doing load testing over there, performance testing over there. Clear?
Yep.
Okay. Now in your Anypoint Studio, it's a very rich tool where inbuilt Maven will be there, inbuilt Git will be there, inbuilt JDK will be there, right? All these are inbuilt. I don't need to do anything. Even our Mule runtime will be inbuilt over there. Mule runtime. If you download latest runtime will be there. You can create automatically once you deploy the application, it automatically creates a server for you, Anypoint Studio, and then deploy your application on that server. Host your application on that server. Automatically, Maven is there, JDK is there, Mule runtime is there, Git is there, everything is there. MUnit is enabled automatically, right? All these things are there in that Anypoint Studio. That's the reason we use that Anypoint Studio, right? So implementation is clear. Now you source control your code. The moment you source control the code to your code repo, which is your GitHub, automatically this CI/CD pipeline will get triggered and it will deploy. It will first build your code. It will run the unit test cases and it will deploy it to the dev environment first. Clear? First phase will be deploying to dev environment. Clear?
Yes.
Okay. So for that, we'll be writing CI/CD pipeline. I'll show you. We have dedicated session for that. Don't worry about right now. Let's see just this a black box which gets triggered the moment you source control the code to your code repository. And it's build your code. It deploys the dedicated environment, whichever environment you are configured. Clear? So that is your implementation. Now, once you implement, once you deploy, once you run the test cases. So now if I go for my API lifecycle stage, I am done with the design, right?
Mm-hmm.
So this is my design phase. I am done with publish. I am done with what do you call implementation. I am done with test. So in between, the deploy will come. Okay, so I'll say this one.
Yes.
Okay. Once the deployment is done, so that means your app is running under your runtime plan. When environment, I say, I don't want to use those terminology right now. So your application is running now. Your app is running over here. Okay. Now, since your app is running over here, you need to now apply the governance. What do you mean by governance? So we want to apply the security. Okay. You want to scale it whenever there is a traffic scaling, whether it's a horizontal, vertical, you want to undeploy, deploy, all those things. You want to apply the policies, right? All these things is come as part of governance. Now this governance, so right now the deploying, undeploying, that will be managed by runtime manager. Scaling horizontally, vertically, that will be managed by runtime manager. Now related to security, okay, security will be managed by API manager. So what kind of policy is supposed to apply and all that stuff. So to apply the policies in API manager, we'll be creating instance. And on that instance, we'll be applying policy.
Will we see that in like detail?
Yes, we'll be creating demo. We'll be, so I said, right, hands-on will be there. Don't worry about it. Whatever topic we are discussing here, for every topic, there is a dedicated session. Okay. Okay. So once you apply this, you create an instance, you connect that instance with your implementation, you apply the policy, your API is secured now. Okay. Now your client directly, they cannot access. They need to go ahead and give the credentials. First, request for the credentials, and then they will get the credentials. They will access your API. Now everything is working fine. It's deployed. It's running now. Up and running. Running is not a stage. Okay, I'm just mentioning here. Everything is working fine. Now, as a owner, as a stakeholder, I wanted to know that how this API implementation is actually behaving. What is the performance? Now that has to be done via monitoring. There is a phase called monitoring. Okay. So after deploy, you'll be going to monitoring phase. In the monitoring, you will be able to see the proper numbers, proper metrics saying that, okay, for these many requests, what is the performance time? What is the throughput? What is the request? What is the response time? How many requests my API is able to handle? How many times it's rejecting the request is? How many requests actually within 1 minute or within 1 second, how many requests are getting served by my API? What is the average response time? What is the minimum response time? What is the maximum response time? All those things I need to know, right? Then only accordingly, I'll be able to either, if I need to scale it, I'll go ahead and scale it. If I need to scale down, I'll go ahead and scale down. Clear? So all those matrices I'll be able to see in the monitoring section. So in monitoring sections, we have multiple tool called, we have tool called visualizer. We have tool called monitoring. In under monitoring, we can go ahead and create dashboards. And these dashboards will give me a proper data. Okay, so visualizer and monitoring will be very, very useful to see my application network. Not only this API, I'll be able to see other APIs also, how my complete application networks is actually performing right now, the current state of that application network. Okay, that will help with the monitoring. So your first page is design, publish, implement, deploy, test, monitoring. Okay. Clear?
Yeah. Yep.
Okay. And for each and everything, we have tools. Okay. All those tools we talked about.
Okay.
Clear? This is your API lifecycle in detail. Okay. Okay. Now, if we go ahead and talked about this API lifecycle, are you clear, Kunal?
Yes.
Okay. Now let's talk about why this API-led connectivity, or what is actually this API-led connectivity means. There is a concept, right? You might have heard this.
Yes.
What is this? Okay. So API-led connectivity is something is a MuleSoft concept. Okay. MuleSoft concept. Actually, I would say this is not MuleSoft concept. This is actually old wine in new bottle. Don't take me wrong way. Okay. Just okay. Old wine in new bottle. Okay. So again, I'm saying, since you're not from Java background, in Java background, there is already a concept called MVC pattern. MVC pattern is nothing but this is a model, this is a view, this is a controller. Okay. This concept was already there, but this concept was used in monolithic applications. Monolithic apps. Now, I don't know whether you're aware of what is monolithic apps means.
No, I'm not.
Okay. So monolithic app means for one requirement. Okay. So once you get a requirement from the client, you'll build a single big app, and inside that app, everything will be there. All boxes you are keeping in this particular application. Whenever you're deploying it as a one unit, single unit. Whenever you want to scale it, you go ahead and scale this single unit. So if you are scaling, you'll be scaling this guy, this guy, this guy, this guy, this guy, this guy. Even you don't need to scale this, but still you are scaling because this is the single huge app that is called monolithic app. Now, if you get any problem, all your application is down. Since say this block has a problem, entire application is down. If you want to serve more requests on this, you want to scale it, you need to scale the entire application, right? So this is a very rigid, right? It's not giving you agility to play with a single block. No way, because this is all are connected, which are actually embedded inside one block, and that block will always be deployed as a single unit whenever I want to. So now if there is a problem, I want to fix it, right? It's very hard to identify where is the problem in the monolithic application. Okay, that's the reason. Then after monolithic, there is a concept came, which is what is microservice. Microservice concept came into picture. Now what happened? They have divided this monolithic app into separate APIs, separate services.
Yeah.
All those services will be like an independent unit. This can exist without the actual monolithic apps. Okay. Now this embedded part, if I take this part, maybe this part is logging service. This part is notification service. This part is maybe audit service. This part may be messaging service, right? And this is where you are actually using these all blocks. So this block is getting used here. This block is getting used here. Since it was hidden, nobody was able to reuse this part. Nobody was able to reuse this part. Now, since I made them a separate block, independent block, now in future, if I implement one more app, I can easily use this independent. Now these are independent, right? Now these are running maybe I can deploy this microservice on a separate server. Any point of time I can scale it without touching any other block. If I have any problem, I'll just go ahead and check that particular microservice only. So fixing bugs, deployment is easy. If you want to scale it, you can scale. Go ahead from one server to make it deployed on 2 servers. So that's where microservice came into picture, and that was helping us to easy our job. And the help of microservice, now we are able to reuse, because it's an independent service, anybody can use it, right? So that's where reusability came into picture. That's where agility come into picture. Reuse. Now, if you are doing reuse, definitely we are saving time, right? Development time, testing time is reduced, right? It is properly tested, is properly deployed, is properly running. So my time is reduced now. So my next app, so my future work will be very fast. The time to market is reduced. All terminology I'm bringing here. Time to market is reduced by using microservices, by using reusability, by allowing scalability, by using agility. Clear? So that monolithic. So what happens now? Instead of writing entire code in one application, we have divided. So this guy, MuleSoft, recommended this approach called API-led connectivity. Now, what is this API-led connectivity? If you look at this app, what it does, okay, let me go to the new page. So this app was monolithic app, right? So it's actually same app is rendering the UI. Same app is getting data from databases, okay? And then same app is playing with this data. So processing data to render it into the UI. Okay, so get the data, which is nothing but a model. Rendering the data, which is nothing but a view. Processing data is nothing but a controller. Okay, now you see the MVC pattern, model M, view V, and controller is C. This was already there in Java terminology or in the old technologies. This was already there, but this was actually hidden inside one app. That was the problem. Now that's the reason I said the same MVC pattern we are rewriting now. That's the reason I used that word called old wine in new bottle. Let me talk about that. So now, if you are getting data from the target system, right? Or you're putting data in the target system, what they have done, okay, can we remove this part from here and call it a system API? Now, other applications, there'll be 100 applications in your organization which want the data from this particular database. Let's say this is your employee database, right? Now, do I need to write that same logic here again and again? No, I have already created system API. To reuse this system API in this application, these applications, I need to tell my organization, other people that, hey, boss, to get the data from this employee table from this specific XYZ database, I have already created a system API. Now, this information has to be published somewhere. Then only people will be aware of that there is already system API to get the data from this table, from this database. Am I clear? Kunal?
Yes.
Where we'll publish this? We'll publish it to the exchange. Publish it to the exchange so that other people will come to know that this system API is there. Write proper documentation for this. We need to write the proper documentation for this API. Okay, what all resources are there? What all methods are there? How the data is, look like? All that. Either whether I need to pass any header parameter, URI parameter, any securities applied. All that information I need to write for the system API in the exchange documentation. The moment I give this proper information in the exchange, I am actually publishing it in the marketplace so that I can sell this API, other people can reuse it. That is where reusing come into picture. Hey, if you don't tell other people, how they will come to know that there is a system API, right? If you don't tell them, again, they will implement that, right? So microservices were there, but nobody were aware of those microservices. That's the reason, again, all other teams were implementing that same API again and again, because there was no sharing of information. So MuleSoft focus on that sharing of information. Unless you tell you have a system API, how the other team will come to know, right? So that is where they publish it to the exchange and put it in the exchange with the proper documentation. So now whenever somebody wants to reuse or implement some use case, they will go to exchange first and they will do discovery. That is called discovery. Hey, for this requirement, is there anything already implemented? If that is yes, then they will just simply, if that API is secure, they will put an access request over there. They will get credentials. They will start reusing it. Am I clear so far?
Yes.
Right. So that is where reusability come into picture. Now that is what about the system API. So getting or unlocking the data. So now if you remember in your application, monolithic application, you'll be writing your custom code over here, right, to connect this database.
Yes.
Now you don't need to write that custom code there. We'll be writing at only one place in the system API. Now today I am connecting to get the employee data from this database. Let's say tomorrow I am changing database. I don't need to change any code over here. I don't need to change any code over here. I don't need to change any code over here. I just need to change over here. Because the connecting to system API is the same. I'm not going to change. Only I'm changing, instead of connecting to this X table, X database, now we'll be connecting to Y database. Maybe in past it was MS SQL. Now we are connecting to MySQL. Only I need to change over here. Now see how easy is this, right? Now let me go back. So getting data from the target system, that is one we have converted into a system API. Now processing data, that means we are writing some logic to process, filter the data, massage the data, polishing the data. Now that is nothing but the orchestration. We are writing orchestration logic over here. Okay. Now this is nothing but a process API in MuleSoft. Process API. This is second layer. This process API will be calling your system API to give me the data.
Got it.
Right? Now this process API can call multiple system APIs. It's up to you. It's like it can have its own business logic over there. So actual business logic will be there in this box. Processing a data. System API will be always lightweight API, very lightweight. Connect the target system or source system, get the data. That's it. You should not perform any business logic over here. You should perform business logic over here in the processing API. Right? Finally, once your data is ready, right? Somebody has to consume it. Correct? Who will consume it? Your UI will consume it. UI is nothing but your experience API. Experience API. Clear?
Yes.
This is nothing but a 3-layer architecture that is called API-led connectivity. Let me define this in proper way now. I'll give a proper example, okay?
Yeah.
Layman perspective, I'll try to explain this, and I have a very good example. I'm a foodie guy, so I'll always try to map with the food, okay?
Yeah.
Now, Kunal, you want to cook an egg curry. That is your requirement. Egg curry. You have family members, okay? So you want to cook this curry for, let's say, 5. You have 5 family members. Your mother, father, you have 2 siblings, and you have, let's say, grandfather. Okay, so 5 people. You want to cook this curry. Sorry, POPLE. Okay. Now, so to cook the curry, definitely you need to get the, okay. So first you need to get to the, go to the kitchen. In the kitchen, you'll be finding containers. All the containers are there, right? Oil container, your tomato container, your masala container, all. So that means your data is hidden in these boxes. So you need to unlock this first. So that means you need to prepare a system APIs for these guys. So that is unlocking the data, you'll be creating system API. So all system APIs will be here, sys APIs. Dedicated for each container, a separate system API. It should not combine with 2 containers, okay? You should not create one system API to get the eggs and get the masala. No. Have system API to get the eggs, have system API to get the masala, have system API to get the oil, have system API to get the tomatoes. Okay. Specific responsibility, lightweight APIs, that is called system API. Okay. Now your eggs are ready here. Raw eggs are there. Your masala is ready. Your onions are ready. Your tomato is ready. But you need to cut them. You need to prepare them for the egg curry, right? So you need to boil the egg. You need to cut the onions. You need to cut the tomatoes. You need to bring the as per your taste, you bring the masala. Right? Now, once your eggs are boiled, once your onion is ready, tomatoes are ready, your masala is ready, you'll put it in the pan. You'll put oil over here. Right?
Yeah.
That's where your egg curry will be. So this is your pan. So this is your one process API, this is one process API, this is one process API, this one process API, one process API. Clear?
Got it.
Now you cook the egg curry over here. That means in the process API, you are actually getting ready your data. getting ready food, getting data ready. Getting data for use. Am I clear so far?
Yes.
System API will give you raw data. Okay, raw data. You should not perform any logic on the system API. Just get the data. That's it. You prepare the food over here on your kitchen. This is your platform. I say kitchen platform. Kitchen platform. You need, so when I put the pan over here, other than oil, we need a gas also, correct? Now, once your egg curry is ready, now this is your dining table, which is your experience API. Experience API. Now on experience API, now you have these 5 people. They wanted to consume this egg curry. So they wanted to consume this data, which is ready in process layer. Now somebody wants to eat this egg curry with chapati. Somebody wants to use this, eat this curry with rice. Somebody wants to use only egg curry and eat the eggs. That's it. Somebody wants to eat this egg curry in the bowl. Somebody wants to use this curry and do something else. I don't have options now, but yeah. So you got my point. 5 people wanted to eat this egg curry in 5 different ways. That's where my data is available in JSON. Okay. Now this is the experience API. So for each experience API used by a target system or our clients. So one client want to consume the data in JSON format as it is. So I'll give that JSON as it is to this guy. In this, he will simply take that data and give it to the client. Now this client, one client was wanted to have this data in XML format. So my experience API will have simple JSON to XML format. Only transform logic over here. So that will convert that JSON from the my process API into XML and give it to the client. Now this experience API don't want all the content from this JSON. So it will take the JSON, filter it, and give it to this client. So this is a client C1, this is a client C2, there's a client C3, there's a client C4, there's a client C5. Now those are sitting on my dining table, right? I need to give them according to their requirement. And to get, today I have only 5 people, right? Now tomorrow I'll get more guests, let's say. I'll be creating a different experience API from them. Okay, if their requirement is exactly similar to my grandfather, then I'll use that experience API. If their requirement is different, then I'm not going to touch, or I'm not going to go and change mine. Why should I change my grandfather API? No, I'll create temporary API, or maybe if they are going to stay with us, we'll create an experience API for them, and we'll simply, they will call this process API. Now look at this. My process APIs, I have implemented only once, and it's getting reused by see how many experience APIs. Now these experience APIs are a dedicated requirement. Right? So this experience APIs will be using my process API. Process APIs will be my system APIs. And system APIs will be actually unlocking the data from the containers. Clear? Everything is clear?
Yes.
Okay. So you will never forget this. Okay. So this is how I explain the API-led connectivity to anyone. Okay. Now experience API, lightweight, system API, lightweight, only weight will be there here in the process API. So if you don't need to implement the bulkier APIs, that's why I said like, boil the egg in separate container, cut onion in separate, cut tomato in separate, okay, and get the masalas in separate. Then I'll write my business logic over here. So tomorrow, if somebody wants to, prepare a vegetable, mixed veg vegetable, right? So mixed veg vegetable, if they will get the onion from here, tomato from here, masala from here. That is called reusability. Yeah. Right? If I do and cut and everything here, right? then there is no chance of reusability. So always try to go, keep that mind in your head that, okay, reusability has the first vision of the MuleSoft. Mission and vision, reusability. Make these APIs discoverable. If you don't tell people that, okay, now again, you cook the curry. Now what happened? You cooked a curry a little more. You don't want to waste it. What you will do? What you will do? Either you go to the neighbors and give it, or just in front of your house, you put a stall, okay, and keep this curry over there, and put a message. Anybody can come, pay 5 rupees and get 1 bowl of egg curry. This message has to be there. So that is nothing but when you are publishing to the exchange, you need to write that message. That message is nothing but documentation of your API. What this API actually does. Okay, unless you make it user friendly, nobody will use your API. There is no time, buddy. Okay, Kunal, there is no time in people's head or people's bank account. They just simply they simply want easy thing. If you don't create any user friendly product, your product, damn good, nobody will use it. So your product has to be catchy. All the user manuals has to be there. Then only people will be using it. So if you put this curry outside of your house and put the message, whoever is going from there, right? They will say that, okay, today I don't need to prepare the egg curry. I'll just take the 1 bowl from here and done. Your job also done. The outsider also done. So this is how you make your product or services self-discoverable. You don't need to sit over there. Just put a stall, put a message. People will come and take and go. Okay, that's how ATM machine is there. That's how your ATM for cold drinks and all that, right? In US, it's very famous, right?
Yeah.
Correct. So that's all from these two options, two topics today. What is the API lifecycle? What is API-led connectivity? So let me draw a proper diagram now. So what is API-led connectivity? So if you draw this, again, I'm saying only 3 layers are not the only option. Okay, you can go with the 2 layers, even you can go with the 1 layer. It's not. The recommended approach is the minimum, is 3 layer. Experience, process, and system. Okay, here target systems. Okay, so basically the source of, source of or gold source. That means the data. Here data. From here you'll be unlocking the data. Here you'll be writing orchestrations. Here we'll be giving experience, and finally we'll be having client layer here. So here this is a data layer. Okay, this is system layer, this is process layer, this is experience layer, this is a client layer. This is your API-led connectivity for you guys. API-led connectivity. Okay, that's all. Thank you.
Thank you, Ashish. Thank you very much.